Okay, so how is everyone today? Good, I hope. All right, so brief announcement about the schedule, so we're all on the same page there. So first, I think today's the 11th. So concerning the schedule, and then specifically concerning the quizzes. So of course our meeting pattern is Monday, Wednesday, Friday. And according to the way that we numbered everything, today is lecture 24. And then next is 25, and then 26, 27, 28, 29, 30, 31, 32 comes after 31. So this is today. Of course, next week is spring break. So we won't be here. Friday will be quiz 26. All exercises on quiz 26 are going to be redo exercises. And the coverage is going to be up to and including 1/6 star, like that. And then when we come back that Friday, we'll have quiz 32. And that will be its coverage. They won't all be redo. Its coverage will be up 17 to 25. Okay. So any questions about the quiz? Yes?
For the redo, do we have to do all of them that are on there? Or just
No. It's the redo is optional. So in principle, you could just not. Well, I guess in principle, any day you could just not come. but all right. So these are all optional. And remember, the redo is that if you attempt to redo, then your grade will be replaced. So even if you made a 10 out of 10, and then you say, I'm going to do the redo, and then you make an 8 out of 10, okay, well now you have an 8. Also, if you had a 0, and then you make a 10 out of 10, well now you have a 10 out of 10. All right, good. And that is the next thing is that on Thursday, this week, which is to say right there, that's an important day for math folks. What day is that?
Pi Day.
It's Pi Day. So I drew a little piece of pie there. So this is Pi Day. Because it's 314. Haha. So at 1:59 p.m. it'll be 314 159, and the whole math department will be going crazy. Maybe, probably not really, but good. So any question before we get to math? All right. So last time we were talking about distance, and just to sort of retread that ground just a little bit, to review it. So concerning distance. In R1, we have two varieties of distance. We have signed distance, from A to B. And then very often this is referred to as the initial point, and this the final point. The formula is D is B minus A. And then in English, that's very often said final minus initial. All right. So it's called signed because in principle this distance could be negative. So to give an example, we could make the following example. So we're in, Richardson, but generally this area is called Dallas. So we've got Dallas here. And then if you travel southeast, but I'll just, for the purposes of this drawing, I'll say exactly south. If you travel exactly south from here, there's another big city, Houston. And then there's a road that, a highway that goes through these called I-45. It's called I-45 most of the time, and if you don't know what I mean, don't worry about it. And if you do know what I mean, I'm just going to keep calling it I-45. So, when you're driving on the highway, every so often you'll see a little sign that's the number, it just has a number on it, and that's called the mile marker. And it's basically telling you, it helps you figure out where you are. Okay, so then suppose that you're traveling, we've got these 2 points. And this happens to be at mile marker say 50. I have no idea if there really is a mile marker 50 in Houston city limits. And then suppose that this point is at mile marker what? 230. All right. So there's a nice little drawing there. So then I could ask, what is the signed distance from Houston to Dallas? So from Houston to Dallas. So that means that the initial point is Houston and the final point is Dallas. Okay. So what would I have to write? D is what?
230 minus 50.
Very good. So 230 minus 50, which is 180. Okay. So no surprises there. Then I could ask, what about what is the signed distance from Dallas to Houston? So now what? Yeah. So now it's always going to be final minus initial. So final position is 50, and then initial position is 230. So this would be negative 180. So notice that those two are the same in magnitude, but opposite in sign. So this one is positive 180, and that one is negative 180. Now, under normal circumstances, when we're talking about driving and distances, usually don't say negative, but fine. So in the diagram, why is this one positive, according to the diagram?
Speed is smaller than 8.
Okay, but even still, ignoring the actual numerical values, there's a reason why in the diagram
Going with the world.
yeah, is that notice it says from Houston to Dallas. So initially we're at Houston and we're going toward Dallas. So what it's saying is that we're starting here and we're traveling toward Dallas, like that. And to indicate and record the sense of our travel, I can put a barb right here. And then if we had some phenomenally large ruler, and we were to measure this, it would measure 180, and we would say that it's positive 180 because the barb is going with the world. Whereas in the other way, it says from Dallas to Houston. So initially we're at Dallas, and then we travel to Houston. And to indicate the direction of travel, I'll make the barb like this. And so if we were to take, again, that phenomenally large ruler and measure this green, then it also would be 180. But we would call it negative 180 because it's the opposite sense, right? The world, the highway, the numbers increase going that way, but we were going that way. So that's negative 180. And then you can just say, well, from the point of view of arithmetic, it's positive 180, negative 180. But those two things are the same thing. This is the arithmetical manifestation of the fact that these barbs are pointing in opposite directions. Good. Any question about it? Now, you could reasonably think, it seems to me that you could reasonably say something like, well, okay, negative miles, I'm not sure that makes sense. And it doesn't make sense in the sense that I suppose that this would mean that from Houston to Dallas, tank your gas would be, you'd be getting less, right? The fill meter on your gas tank would be going down, and then I suppose if you turn around and went the other way, then I guess you'd get more gas. Okay, but it doesn't really work that way, where gas consumption is used. But there are plenty of things that do change, both in positive and negative directions. An example would be that if we ignore that is we're talking about highways, and if instead I say that I'm holding up this little binder clip, and so I'm holding it up. It's hard to see how much I'm holding it up. So I'm holding up one hand width, above the page. And then if I hold it up that high, then it has potential energy, positive amount, and it has 0 kinetic energy because it's not moving. But if I drop it, okay, it fell down, and its potential energy went down, and its kinetic energy until it hit went up. So while it was falling, its kinetic energy was positive, and its potential energy was decreasing. And if I pick it up, that's undoing it. So, all the time I move it up and down, the kinetic energy is going up and down, and the potential energy is changing. Same thing here. Right? Okay. We also want a unsigned distance. So the unsigned distance from A to B. So in this case, what we mean by unsigned is essentially, notice that if you do it in this order, you get 180. If you do it in the other order, you get negative 180. The unsigned distance is, we'd want to say that we always want to pick out 180. We always want it to be that one instead. So you could just say that this is D is B minus A. So that would be the unsigned, that would be the signed distance. But how do I modify this formula to make sure that we always pick out the positive one? Or the non-negative one, really?
Absolute value.
Yeah, absolute value. So this would be the same as absolute value of A minus B. So you do the subtraction in whatever order seems best to you, and compute absolute value. All right, good. So then in R2, there is no signed distance. There is no signed distance because, if you were to have 2 points, A and B, and you were to say that you're going to travel like that, I'll put the barb in the middle. Then, if you happen to be on this side and looking at it, then because of the right-handed convention, you look at this and say, oh, it looks like they're traveling to the right. So you'd say, so I guess if I had to say it was anything, I'd call it positive. But then if you were to walk around to the other side and look at it from this point of view, then from this point of view, they look like they're traveling to the left. And because of the right-handed convention, you conclude that this is negative. So the reason why you can't do this on this highway, in this highway example, is because the whole world is the highway. You're not allowed to leave it. You can't look at the highway from off of the highway. Doesn't make any sense. So it's a one-dimensional world. So here we're talking about a one-dimensional thing, but sitting inside of a two-dimensional world, it can't have a sign. So from this point of view, it looks positive. From that point of view, it looks negative. So it's not possible to say that it has a sign. Okay. As for the unsigned distance, just reviewing that very quickly. If we drew a nice diagram last time, so I'll just do this part quick. So if we have 2 points, x1, y1, and another point, x2, y2, and we're doing this, we want to know how long is that, what's that length there. Then the way that we did it is we said, okay, since it's on a plane, we can come up with a two-dimensional coordinate system, and then using that coordinate system, more or less, we can set up a right triangle. And that right triangle looks like this. We've got a right triangle. And, then we can say, all right, now concerning these legs, so in a right triangle, the side opposite of the right angle is called the hypotenuse, and these two are the legs. We figured out the distance. We called eventually this one delta x and this one delta y. Okay, and so specifically, this delta y would be going like that, and this delta x like this. So it's sort of like making a nice diagram saying that if you wanted to travel from A to B, you could first travel like this, and then like that. Okay, and that would get you from A to B. So the formula for delta x is x2 minus x1. You know, because it's final minus initial. What's the formula for delta y? y2 minus y1. Because again, it's final minus initial. Now, on this particular drawing, you could tell me, is delta x negative or positive or what? Delta x. Well, it's going to be positive, because look at how we did it. We said delta x is this one to that one, and it's going to the right. So that delta x is positive. How about delta y?
Negative.
It's going to be negative, because we're going down. And remember that the coordinate system, the right-handed coordinate system, the vertical coordinate increases going up. So, you know, this is negative. All right. So those are signed distances, but then the length, that distance right there, little d, the Pythagorean theorem says that d squared should be delta x squared plus delta y squared. Now I'm leaving something off, but we talked about it last time, and that is that, you know, sort of strictly speaking, when you learned about right triangles in grade school, all those triangles had the leg lengths were positive. And, you know, we talked about putting absolute values around these. We put them there. But then we said, actually, it's not going to matter whether or not we put absolute values. So on this particular example, delta y is negative, but I claim that that won't matter. So why won't it matter? Because we're squaring it. So even if delta y is, say, negative 3, then what we're doing with delta y is we're squaring it. So it's going to square to 9. Okay, so it won't matter. So you could solve for d and say that d is the square root of delta x squared plus delta y squared, like so. And if you had a mind to do so, you could write it without the deltas. And you could just write x2 minus x1 squared plus y2 minus y1 squared. So that's distance. But the main idea in the end is the construction of this right triangle. Any questions about it? So that's just a review of last time. All right, so we want to be able to do a similar thing, a related thing. Midpoint. So again, we're going to solve a one-dimensional problem. So if we have a one-dimensional world, and we have 2 points, A and B, then, you know, if we ask for the midpoint of A and B, what we're asking for is the point that's right in between them, right, halfway between the two. So just eyeballing it, it appears to be about right there. So, you know, M for midpoint, I guess. And then the question is what's, you know, we want to figure out what's its formula. So let's see if we can do a couple of examples. So how about midpoint between 20 and 30. So what is it? 25. Okay, good. How about midpoint between, say, 3 and 16? More hesitation. so it's not 6.5. It's 9.5. Yeah, 9.5. All right, and then this is the kind where there's usually the most hesitation. So midpoint between -4 and 11. 3.5. All right. So, I've just been asking you to just do it, and no formula has been written. So, does anyone care to give us a formula? What's going to be the formula for calculation? B minus A? Okay. Okay. So, B minus A over 2. And then what? Just that? So like if I do that here, that'd be 30 minus 20, that'd be 10, and then over 2, that'd be 5.
Okay, so you gotta add it to A.
Okay, and then add A. So that'd be 30 minus 20, that's 10, over 2 is 5, and then add 20, that'd be 25. All right. 16 minus 3, that's 13. Half of 13 is 6.5. Add 3, that's 9.5. Okay, that'll work. Similarly, and this is where this causes a big problem, is that, okay, 11 minus -4 is 15. Half of 15 is 7.5. And then add -4, that's 3.5. So this works. And this formula, I don't know why, people are just wired this way. This is what people usually use when you ask them the midpoint, if they're not, if they don't have, reason to do otherwise. People seem to do this formula. So half the distance, and then plus the starting point. But here's a better way to do it. It's just A plus B over 2, the average. Let's see if that really works. So 20 plus 30 is, and half of 50 is 25. 3 plus 16 is 19. Half of 19 is 9.5. -4 plus 11, that's 7. Half of 7 is 3.5. Okay, so here's 2 different formulas to do it, and we'll have an exercise where you need to demonstrate that these are the same. They really are the same thing. Okay, good. Fine. So then now what we want to do is we want to be able to calculate midpoint, but for R2. Okay, so we could say something like let A be the point x1, y1, and B the point x2, y2, and we want to find the midpoint M. All right, so here's the idea. So we've got 2 points, A, x1, y1, and B is x2, y2. And we've got, this line segment connecting them. And what we want is we want a point that's on that line segment, and it's exactly halfway between them. So that's what we want. So just eyeballing it, it looks like it's about right there-ish. And we said we said right there that we'd call it M. So what we want is a formula, just like A has two coordinates, x1, y1, and B has coordinates x2, y2, M is going to have two coordinates. And in some sense, what we need to do is, write what goes in there. That's what we need to do. Okay. So the way that we're going to have to do it is we're going to have to sort of see how did we do it here. And what we're going to do is that, we know how to solve a one-dimensional problem. And what we're going to do is we're going to break this two-dimensional problem into two one-dimensional problems. So we're going to solve one problem and then solve another problem. So in the same kind of way that we constructed a right triangle when we wanted to compute distance, we're going to do that same thing here. So imagine that I've got a very, very bright flashlight or whatever, light source, and this line segment is casting a shadow on the horizontal axis. So it's casting a shadow. So the shadow it would cast would look something like this. And that would mark out for us 2 points on the horizontal axis. So what is that point on the horizontal axis? That's x1. And this one? x2. And now I'll hold the light source over here. Very bright light, and now this line segment will cast a shadow on the vertical axis. The casted shadow will look like this. This is a right triangle, but that doesn't really matter so much for our purposes. On the vertical axis, what's that? y2. Wait, why is it not y1? Because it's y2. I agree with you. But wait, if the little one here is called x1, then why is this one not y1? Well, in the end, it's because it's coming from this point, right? So its name is y2. Fine. And then similarly, what's that point? That'd be y1. So, fine. So, as a reminder, what we're doing. We said we've got a plane, we've got 2 points, we want to find that point. And what we've done is we have set ourselves up to solve some one-dimensional problems. So now I'll forget everything except just this and say, hey, look, I've got a horizontal axis there. That's nice. And I feel like computing the midpoint for some reason. Eyeballing it, it looks like it's about right there-ish. So what's going to be, what is that point? Right, so it's the average x value. Okay, similarly, looking at this one, we want to find a midpoint. Just eyeballing it, it appears to be right there-ish. And then what's its value? Very good. So now, the point, A point that I want you to see is that I drew the diagram and then I covered up the rest of it. And I found this midpoint without looking at anything else. And I found that midpoint without looking at anything else. And now here's the question, is that if we, again, reveal the diagram, we want the coordinates of that point right there. That's what we want. And now if I take my flashlight again and I hold it up here and just let, arrange matters so that only that point casts a shadow, then where will that point's shadow, where will it lie? Right there. As a result, what do I write right here? Right. So this is x1 plus x2 over 2. Similarly, if I take the light source and hold it over here and let M cast its shadow on the vertical, then do you see where its shadow would hit? Okay, so this is y1 plus y2 over 2. Beautiful. Any question about it? Okay, so, you know, this pattern continues as far as you care to take it, right? We've got R1, we've got R2, there's also R22. And instead of there being, in that case, instead of there being 2 coordinates, right, this one and that one, there'd be 22. And if you had 2 points in 22-dimensional space, the midpoint between them would have 22 different, you know, positions, 1, 2, blah, blah, blah. And every position, it would just be average, 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 all the way down. Any question about it? Okay, so here's a typical kind of question. Let P be the point 2, 4, and let Q be the point -3, 1. First request. Plot P and Q. 2. Sketch the circle which has a diameter with endpoints P and Q. And then 3, find the center and the radius of the circle. All right. Fine. So then, to that end, I'll put this. So for P, in which quadrant is point P? It's in quadrant 1, which is to say the top right. The way that you can see that is, again, just looking at the coordinates one at a time. So that is the horizontal coordinate. And because it's +2, that means it's in the right half. So that's that's saying right half. And that is saying top half. Okay, so it's in the right top. Similarly, Q is in, so left and right. Which side is Q? Left, because of that. And bottom and top, which side is, which half is Q on? So it's the top half, right? So it's good because of that. And so it's in quadrant 2. Very good. So then point P, right 2 up 4. And then point Q, left 3 up 1. Like so. All right. So part 2 kind of requires a little bit of explanation. So, you know, for part 1, we just did that. So for part 2, you've got to understand a little bit of the language here. So if you have any old circle whatsoever, so any circle there, then, and you choose some point, so say like this point. So that's a point on the circle. Then corresponding to that point is another point that is the furthest possible point from that point. So, for example, there's another point that's on the circle, but is that the furthest away you can get? Nah, you can get further away, right? So the furthest away you can get, according to my eye anyway, is about right there, like that. Okay, so then like so. So this this line segment that we just drew, it's referred to as a diameter. A diameter. And you know, in English we have two articles. Well, we have more than two, but at any rate, mainly two. One of them is a, and the other is the. So I'm saying a diameter and not the diameter. When you say a diameter, that indicates non-uniqueness, because after all, if I choose, say, this point right here, then the furthest point on the circle from that one is about like right there-ish. And you know, that green that I just drew is another diameter. So a circle has infinitely many diameters, because a diameter is that line segment, and you could just twist it around to get another one. But when you say the diameter, you're talking about the length of any one of those diameters, because all those diameters have the same length. That's what it means to be a circle. So, so I say which has a diameter within points P and Q. So I mean a circle that's going like that. But then I ask for the radius, which means that I'm asking for a number. So like this right here, that is a radius. And here's another one. That's a radius. That's a radius. Here's another radius. But when you say the radius, you're talking about the length of any one of those radii. Fine. So to help us complete part 2, I'm going to do part of part 3 first. Part 3 says find the center and the radius. Okay, so concerning the center, so of course center means the part that's right in the middle, the point that's right in the middle of the circle. How can we find the center?
Create a triangle where the hypotenuse is line segment QP,
Mm-hmm.
and then find the midpoint thereof.
Very good. I love it. So we've got this line segment here, something like that. So that's a diameter. Then do you observe that the center of the circle is at the midpoint of every diameter? So the center of the circle is the midpoint of every diameter. Okay, so we could say it like this, that C is for center is P plus Q over 2. All right, so let's calculate. So that'd be in the end it'll look like this. So something like that. So something comma something. So it'll be the average x coordinate, so 2 plus negative 3 over 2 in the first coordinate, and in the second coordinate 4 plus 1 over 2. And then now I'm going to make an error, an arithmetic error, for purposes of illustration. So suppose I look at that and say, okay, 2 plus negative 3, okay, so that'd be half, like that. And then this one, 5 over 2, that's 2.5. All right. So then really that should be -half. Okay. But the reason to make that error is I want you to see that the picture is telling you it's a very strong check on your response. So let's plot this C as it is currently written. So this says half. You move right half, and then up 2.5. So right half, and then up 2.5. So that's the C that's currently on the page. Now, could that be right? No, that couldn't be right. For several reasons. First off, it's not even on that line segment. Second off, concerning the distances, it seems to me that it's closer to P than it is to Q. So that couldn't be right. So can you see that the calculation and the drawing are, they go hand in hand. There's two ways to look at the thing. So the fact that that point doesn't look like it's in the right place is telling me that, oh, I made some kind of calculation error. So, go back and check, blah, 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 blah. Oh, look, there it is. It's right there. That really should be -half. And then as a double check, now I'll plot that point and say, okay, left half and then up 2.5. So left half and then up 2.5. Does that seem right? Yeah, that seems right. That seems reasonable. Okay. So then, fine. We can plot the circle now, that I can see its center. Really, this is just a sketch. So sketch is like code for I'm not going to get out a protractor. Oh man, that's terrible. Okay, but you get the idea. Finally, in the closing moments here, still plenty of time, we need to find the radius. Find the radius. And it says the radius, which means that the kind of thing that we're looking for is a number, not a line segment. So here's what I mean to say, is that this is point C here. Oops. This is point C. So there is a radius that goes from C to P, and there is another radius that goes from C to Q, and there's another radius that goes from C to whatever that point is. But we don't want the segment, rather we want the distance, right? We want the length. So for the radius, here's several possibilities. We could find the distance, which is to say the unsigned distance, from C to P. That'd work. Or we could find the distance from C to Q. That would work. But now concerning these are a little bit clumsy, just a little bit, because C has fractions in it, right? It has decimal points. And it'd be nicer if they were all integers, right? It'd be a little bit nicer. The arithmetic would be slightly more convenient. Notice that P and Q have integer coordinates, 2, 4, and -3, 1. So, or I could calculate the distance from P to Q, but I'd need to do something else. What? Then divide by 2. Because the distance from P to Q is the diameter. Then divide by 2. Okay, so I'll do that very quickly because we're hitting the clock here. So then doing that, I'll calculate delta x. So delta x, that'd be -3 subtract 2, which is -5. Delta y would be 1 minus 4, which is -3. So then the distance there would be the square root of -5 squared plus -3 squared. So that's 25, and that's 9. So that distance would be square root of 34. And so is that the answer? No, right? What that is that's the diameter. So then as a result, the radius would be square root of 34 over 2. And that's an R. Very good. All right, so I hope you have a wonderful Monday.